Earth, our planet of origin. This is where our trip begins, a little blue dot floating in the vast cosmic ocean, home to every person you have ever met, every human who has ever lived, and every narrative ever told. However, as we zoom out past the moon and beyond our atmosphere, as we depart from Earth's embrace, we set out on an epic mission to understand the full grandeur of our cosmos beyond the familiar planet and sun. The first marker on our cosmic journey is the moon, about 384,000 kilometers away, a distance so vast that if you were to drive a car at a constant speed of 100 kilometers per hour, it would take you over 160 days to reach it. From this lunar vantage point, Earth appears as a fragile sphere of blues and greens cradled in the black void of space, a sight that puts our existence into a humbling perspective. This is Earth as seen from the moon as we continue our outward journey. The next milestone is the Sun, lying approximately 1 astronomical unit away from Earth. This unit is equivalent to about 150 million kilos, which is the standard measuring stick for distances in our solar system. Imagine this light traveling at an astounding speed of 300,000 kilometers per second. It takes about 8 minutes and 20 seconds to journey from the Sun to Earth. If you were to travel this distance in a commercial jet flying at 900 kilometers per hour, it would take you about 19 years. This immense distance is a stark reminder of the vastness of space, even within our own solar system. The Sun, a fiery behemoth, provides life-sustaining energy to our planet. From this incredible distance, venturing beyond our home planet and its solar companion, the Sun, we set our sights on Mars, our enigmatic red neighbor. Mars's closest approach to Earth is about 54.6 million km away. However, this distance can stretch up to 401 million kilometers when the two planets are on opposite sides of the Sun. The large distance between Earth and Mars has posed a major problem for space exploration. It would take up to 50 years to fly there at the speed of a commercial jet. In addition to being far away, the journey that our rovers and probes have sent to the red planet is complicated because of the constantly shifting orbital dynamics and distances. As we travel to the furthest reaches of our solar system, we come across Neptune, a far-off ice giant that is located approximately 4.5 billion kilometers from Earth. Neptune is the boundary of our solar neighborhood. It takes sunlight 4 hours and 15 minutes to travel from the Sun to Neptune via the vacuum of space. The Voyager 1 space probe, launched in 1977, is a symbol of humanity's unquenchable curiosity and our ambition to explore the vastness of our solar system. Beyond known bounds, Voyager 1 has traveled for more than 40 years, covering an astounding 22 billion kilometers from Earth. It is the furthest human-made object from our planet, a silent wanderer in the cosmic sea. In 1990, at astronomer Carl Sand's suggestion, Voyager 1 turned its camera back towards Earth for one last picture, producing the famous pale blue dot image. At a distance of roughly 6 billion kilometers from Earth, our planet appeared as a tiny, faint dot in the vastness of space. Sean thought poetically about this image, highlighting our responsibility to cherish and preserve our only home, a small speck in the vast universe. The orbit is a vast theoretical sphere of icy objects located at the very edge of our solar system. It is estimated to extend up to a staggering 100,000 astronomical units from the Sun, or roughly 1.9 light-years, a distance so great that it is on the verge of interstellar space. Scientists have identified the heliopause, the point in interstellar space when the interstellar medium stops the Sun's solar wind, marking the end of our Sun's impact and the beginning of interstellar space. Begins the cloud symbolizes the outermost point of our solar system, a border zone when the Sun's power diminishes and the cosmic voyage into the galaxy properly commences as we leave our solar system. The next interesting object is Alpha Centauri, the nearest star system to the Sun, which is located about 41.3 trillion kilometers away. This distance translates to more than 276,000 astronomical units, AUs, a measure that is so useful within our solar system that it starts to lose its usefulness at such enormous distances. Instead, astronomers use the light year, the annual distance traveled by light, for interstellar measurements. With today's technology, a trip to Alpha Centauri is nearly unimaginable. For example, the Voyager spacecraft, flying at roughly 17 kilometers per second, would take over 70,000 years to reach this nearby star system. Alpha Centauri is located about 4.4 light-years away from Earth. This enormous distance emphasizes the difficulties of interstellar travel and how wide the gap between the stars is. We are currently traveling on the grand scale of our own galaxy. The Milky Way is a vast spiral galaxy with a diameter of approximately 100,000 light-years. It is home to hundreds of billions of stars, each of which may host its own planetary system. Within this immense structure, there is a tiny sphere known as the human radio bubble that extends about 100 light-years from Earth. This bubble represents the farthest extent of human influence in the cosmos. Beyond this bubble, it is as if humanity never existed because no civilizations in the vast majority of our galaxy would be aware of our presence because our signals haven't reached them yet. The Milky Way is so large that our entire recorded history is but a whisper in the cosmic wind, undetectable. After passing through this little bubble and out of the Milky Way, we enter the enormous, nearly unfathomable domain of intergalactic space, where galaxies float in a cosmic ocean separated by enormous distances. Our galaxy is a member of the local group, a little cosmic neighborhood. A grouping of over 50 galaxies dispersed over roughly 10 million light-years. The local group is a varied assemblage that includes many smaller dwarf galaxies in addition to spiral galaxies like the Milky Way and Andromeda. The distances between these locations are so great that it would take 10 million years for light to travel across them. This distance dwarfs everything in our own galaxy. Highlighting the universe's vastness, the void that is intergalactic space is quiet. Beyond the local group, we encounter the colossal Virgo supercluster, an immense collection of galaxy groups and clusters, including our own local group, encompassing a region of space approximately 110 million light-years in diameter, or 33 megaparecs. This vast wilderness between the islands of galactic light in this immense void is our galaxy, home to our entire history, just a tiny speck among many, a single story in the grand cosmic library. As we travel outward from the Virgo supercluster, we arrive at an even more astounding cosmic structure. The Virgo supercluster is a titanic structure in the universe, holding thousands of galaxies from at least 100 galaxy groups and clusters, each with their own myriad stars and planets. The supercluster of Lanaka, on a massive scale, this enormous group of galaxies, which spans more than 500 million light-years and includes the Virgo supercluster, is our galaxy. Lakia, which translates to immense heaven in Hawaiian, lives up to its name with a mass of 100 million billion. Suns with innumerable celestial bodies, galaxy clusters, and superclusters, Lakia is a gravitational masterpiece. In the center of Lanaka, bound in a cosmic web of attraction and motion, the supercluster's galaxies are subject to a strong gravitational attraction from the unexplained great attractor located in the wide Milky Way. The Virgo supercluster and the entire local group are but small parts of this enormous structure. The vastness of the universe begs the fascinating question: if the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the nature of cosmic expansion. Lanakia offers a profound context for our existence in this immense supercluster, showing us that we are a part of something far greater and more majestic than we can fully comprehend. As we approach the limits of our cosmic exploration, we come across the limits of the observable universe, an astronomical marvel stretching about 93 billion light-years in diameter. Since the Big Bang, the universe has been expanding, stretching space, and causing the distances between celestial bodies to increase. However, one of the greatest mysteries of cosmology is what lies beyond the observable universe. Some regions of space are expanding away from us faster than light, rendering them permanently out of our view. As a result, the true size of the universe remains unknown and may even be infinite. The observable universe, vast as it is, may only be a small portion of the entire cosmic expanse, leaving us with the sobering realization that there may always be regions of space, entire galaxies, and wonders that we will never be able to witness as they retreat endlessly into the depths of the ever-expanding universe.